What does home mean? What makes it special? And what can looking up tell us about what's beneath our feet? This is Knowable, and I'm Adam Levy. Our world, Earth, is everything to us. It's just the right size and just the right distance from just the right sun to contain liquid water, allowing it to support life just like us. But for decades, centuries, scientists and philosophers alike have looked to the stars and asked themselves the same question. Just how special is Earth? Are these properties rare, unique even? Or are they a dime a dozen in the vast reaches of the cosmos? Over the past few decades, we've been on a dramatic journey to discover our place in the universe. And around each and every turn, researchers have uncovered new surprises.
With planetary exploration, there's been one general theme, and that is diversity. Everything is more diverse when we look at it than was predicted.
This is space scientist Jack Lissauer, who's based at NASA's Ames Research Center. He's witnessed firsthand how researchers have uncovered this detail and diversity. You see, if we step back just 50 years, the number of known planets hadn't really changed much over the previous centuries. The planets in our solar system fall into three categories: gas giants, Jupiter and Saturn, ice giants, Uranus and Neptune, and terrestrial planets, Mercury, Venus, Mars, and, of course, Earth.
One of the most intriguing questions is whether the Earth is unique, or whether it is simply a member of the series of terrestrial planets, somehow filling the gap between Venus and Mars.
This is a quote from a review titled The Atmospheres of Mars and Venus, published in 1971 in the Annual Review of Astronomy and Astrophysics. Just how different Earth was from its two neighbours, and why, was a profoundly open question back then.
I think there were still people who thought Mars might be very Earth-like in the middle of the 20th century. That was very popular at the beginning of the 20th century.
As time progressed, we studied the planets in our solar system in more detail. The 1970s saw a host of landers from both the USSR and the United States landing on our neighbours, Venus and Mars. And the Voyager probes, launched in 1977, visited the four outer planets of our solar system. Each mission provided more pieces of the solar system's puzzle, shedding light on what the planets are made of, how like and unlike they are, how and when they, and the whole solar system for that matter, came to be. Astrophysicist Avina van Dishoek of Leiden University in the Netherlands is co-editor of the Annual Review of Astronomy and Astrophysics. She's seen how our understanding of Mars, Venus and Earth in particular evolved over time.
Maybe they were born in very similar ways, but we learned how they then subsequently evolved over the 4.5 billion years in different ways. And that is what now makes Earth unique. Venus and Mars may have been born with, for example, similar amounts of water, but evolved very differently.
Put this way, Earth might not seem all that special. Other planets may have had water to begin with as well. Our planet just got a little lucky with its distance from the Sun and a few other choice variables. This perhaps suggests that Earth sits on a spectrum of rocky planet possibilities. But in truth, there's still something pretty crucial that sets it apart.
Of course, the one super special thing about it is that it hosts us, it hosts life.
That's Paul Butler at the Carnegie Institution for Science. So in the 1970s, Earth seemed both ordinary, just another terrestrial planet, and exceptional, the only home to life anywhere in the universe that we knew of. But there was a hefty catch. A few decades ago, we only knew of one single star, orbited by planets, our own Sun. This meant, as that 1971 review explained,
of all the planets which may exist in the universe, only 9 have been studied by man.
But putting Earth in context didn't end with its place among the planets of our solar system. A quest was underway to find out whether other stars did indeed have their own planets. and what those planets were like.
I mean, there were certainly lots of speculations at that time that there would be other planetary systems. Now, whether they had Earth unique or not is a good question. You can find, I think, both arguments.
In fact, some had argued for the existence of planets outside of our solar system, today we call them exoplanets, hundreds of years before. In 1584, Italian philosopher Giordano Bruno argued that
there are then innumerable suns, and an infinite number of Earths revolve around those suns, just as the 7 we can observe revolve around this sun which is close to us.
A heretical claim that may have contributed to his execution 16 years later. Some 300 years after that, in the 18 and 1900s, exoplanet after exoplanet was apparently discovered. For example, unexpected behaviour in the motion of a pair of stars orbiting one another was seen as evidence of an exoplanet as far back as 1855. Reported discoveries of new planets picked up pace in the 20th century, but there was a problem.
There were headlines in the 60s, in the early 80s, about first exoplanets discovered, first planets outside our solar system. But the fact that they were all claiming the first means that they weren't right.
And indeed, one by one, nearly all of these first discoveries were discredited as further evidence emerged. Some researchers, like Jack Lissauer, who we heard from a moment ago, didn't want to wait around for a confirmed discovery to finally come in. Instead, they worked on theories to demonstrate what could be out there. In a 1993 review titled Planet Formation, Jack pointed out that
we have confirmed knowledge of only one planetary system, the solar system in which we live. Thus, at present, theoretical modeling provides the best means by which we can estimate the abundance and diversity of planetary systems in our galaxy.
Of course, with only one solar system to go on, that and some evidence of disks of matter around young stars, such research was highly speculative. Today, with the benefit of hindsight, Jack looks back and can see the limitations of this type of work.
If people made detailed predictions, well, those didn't turn out too well. But in general, I think we were mostly on the right track.
Meanwhile, Paul is somewhat less diplomatic about the early theoretical work on the formation of planets beyond our star.
The one thing that every theory of planet formation had in common was that it was abysmally wrong, not even close. We had intense blinders on.
But back in 1993, it was impossible to check these models against anything. The hope was that finding actual observations of
other planetary systems may eventually provide further constraints.
Eventually. It seems such an achievement still felt far off at this point. After all, a host of technological advances were needed to even open up the possibility of observing an exoplanet. Astronomers needed sensitive spectroscopy to detect the minute motions of stars that would indicate the gravitational tug of an orbiting planet. And they also needed immense computational power and storage to process these data. Then, 2 years later, in 1995, there was an announcement declaring the first exoplanet around a sun-like star. Again, this strange candidate planet was behaving pretty bizarrely. It seemed to be roughly the mass of Jupiter, but rather than being far out from its star, it was apparently spinning round at close range, making a complete orbit about every 4 days.
And mostly everybody thought it was wrong because, first of all, every claim of an extrasolar planet up until that time had been wrong. And secondly, everybody knew you couldn't have a Jupiter-like planet in a 4-day orbit. It was just insane. We happened to have 4 nights on the telescope the next week. And, we went up to the telescope pretty skeptical, thinking this isn't going to pan out. And at the end of 4 days, we were stunned with the results because they were dead on right. This thing existed. It had a 4-day period. They had just done a really spectacular thing. And this thing quickly went around the world. And within about 3 or 4 days, our phone started ringing off the hook. New York Times, the Washington Post, every science magazine.
And the coverage in the media was pretty breathless. understandably so given that this was the first finding of a world around another sun. Here's what the New York Times reported on the 20th of October 1995.
If these sightings are borne out by further research, the discovery would have profound philosophical as well as scientific implications. It would remove any pretension that the solar system is unique, and the likelihood that there are many other planetary systems increases the chances of there being life, perhaps intelligent life, somewhere else in the universe.
But not everyone was so bowled over. In fact, Avina remembers a very different response from the academic community at the time.
Well, it didn't come as a surprise. Of course, the composition, the architecture, that came as a surprise. But I think everybody was just waiting for it to happen. And to some degree, there were so many negative results on searches for exoplanets that it almost felt like, what is happening here? What is wrong? What are we doing wrong? Why are we not seeing these exoplanetary system? That it came actually as a sort of relief that they were found. And then
Relief or revelation, this first true exoplanet clearly showed that other stars' planets could be very different to those we know of in our neighbourhood. While some planetary scientists had entertained the possibility of such a massive planet orbiting so close to its star, that certainly hadn't been the focus of the search.
This is part of the reason it took so long, because people were looking for things more analogous to our solar system. Maybe a Jupiter a little bit closer, or a little more massive, or the like.
Over the coming months, more of these so-called hot Jupiters would be uncovered, demonstrating how commonplace such a seemingly remarkable type of planet actually was. Paul, who we heard from a moment ago describing his verification of the first exoplanet, hunted down the next handful. In 1998, he co-authored a review for the Annual Review of Astronomy and Astrophysics detailing the first 8 planets to be uncovered. Titled Detection of Extrasolar Giant Planets, the review didn't hold back from reflecting on the lengthy history of this search.
For 2,000 years, prevailing scientific principles have provided rationale, both for and against, the existence of other planetary systems.
The review goes on to note,
Already, the large eccentricities and small orbits of Jupiter mass companions found to date resonate with the Copernican lesson.
In other words, these huge planets with their tiny orbits reinforce the Copernican model of the universe, namely that Earth is neither its central nor its typical actor. But the search wasn't over yet. After all the planets that had been found so far were reminiscent of the biggest planet in our solar system, the gas giant Jupiter. So the question remained, could astronomers track down Earth doppelgangers? In the very same issue in which Paul detailed the discovery of the first 8 exoplanets, another review titled Astronomical Searches for Earth-like Planets and Signs of Life detailed how much work was left to do.
The technical leap needed to detect a similar planet of even the closest solar-type stars requires the ability to deal with extreme contrast and dynamic range.
This would require years of work, new telescopes, tools, and techniques. But even in 1998, this seemed to be on the horizon.
We live in a fortunate time when space exploration could realize the dreams of past generations of finding Earth-like planets and life independent of the Earth.
As the years ticked by, astronomers got better at uncovering solar systems other than our own. The first exoplanets were discovered through the wobble of their host star, revealing the minute gravitational tug of a planet. But increasingly, astronomers found planets as they moved in front of their star, causing the light to dim ever so slightly. A combination of these methods allowed scientists in 2009 to report discovery of the first potential rocky planet. And in the same year, a dedicated planet hunter launched. This Kepler space telescope allowed astronomers to watch out for the telltale dimming of stars with unprecedented frequency.
We have a new discipline here, and it really grew from virtually nothing in 1995 to one of the major parts of astrophysics. No one could have predicted how rapidly exoplanets would grow.
Among the planets that were found were more and more remarkable systems that defied expectations. Planets with wildly eccentric orbits, vastly dissimilar to our Earth's nearly circular path. Planets orbiting 2 stars rather than 1, and planets that were reminiscent of Earth in scale, but orbiting far closer or around far smaller stars.
If I look back, I think we lacked a little bit imagination. I think we now know there is a much larger diversity of planetary systems than we had ever imagined, and also different types of planets.
Paul, who has been involved in the discovery of many of the thousands of worlds we now know about, has relished uncovering all these surprises.
I mean, the fun part of this whole journey is that at every step the theorists have been wrong. And at every step, the observations have driven the theorist absolutely insane. So as an observer, that's basically as good as it can get.
And observers have been seeking to find out as much as they can about these planets. It's now not unusual to estimate the size and mass of exoplanets. But given that the closest are some 700,000 times further away than Mars comes to the Earth, other details are hard to come by. But astronomers have uncovered interesting features. These range from hints of possible volcanic activity to claims of orbiting moons. Piecing together what little information we can glean could help astronomers answer one of the most intriguing questions of all: whether any of them harbour life.
Unless the aliens are really kind and send us, their TV shows or their Encyclopedia Britannica or whatever on the radio, it's not going to be easy to find out if a planet has life.
So far, we've received no such radio signals, though there have indeed been hunts for them. In lieu of such a helpful alien tip-off, exoplanet astronomers are hunting for the best evidence they can hope for: the atmospheres of exoplanets.
The exoplanet atmosphere is the only way to infer whether or not a planet is habitable or likely inhabited. The planetary atmosphere is our window into temperatures, habitability indicators, and biosignature gases.
This is from a 2010 review on the topic, titled simply Exoplanet Atmospheres, and published in the Annual Review of Astronomy and Astrophysics. The review describes the atmospheres observed so far. At the time,
hot Jupiters dominate exoplanet atmosphere science.
While such planets don't offer much hope for signs of life, the review also speculates on what astronomers could look out for on more likely candidates. It explores the characteristics of Earth's atmosphere that could be attributed to life, which astronomers might hope to one day spot in alien atmospheres. Today, still, astronomers can only tentatively confirm that they have observed the atmospheres of rocky exoplanets, and many hope that the next generation of telescopes will finally begin to open the window into these far-off worlds.
I think studying the atmospheres is absolutely the exciting next step in this research. We now know statistically how many of these planets there are, what type they are, but now we really need to do the next step in characterizing them and what that actually tells us about habitability, but also their formation.
In the quarter century since the first exoplanet around a sun-like star was discovered, the field has exploded. With new planets continuously added to the roster, and with ever more details uncovered, it might seem like we now have a pretty clear answer to that very first question. How special is Earth? Or so you'd think.
Yeah, how special or unique Earth is still a question that remains to be answered. We certainly know that there are other Earth-like planets. We also know that there are Earth-like planets at the right distance from their mother star for water to be liquid. I don't think we know the answer yet if we are thinking really of the twin of our sun.
And the reason for that is those planets are extremely difficult to discover. If we are going to estimate how common Earth-like planets are in terms of just size and orbital period, we have to extrapolate from the data we have.
Extrapolating to estimate how common it is for Earth-like planets to go around Sun-like stars relies on assumptions. And given how often exoplanets have confounded researchers' expectations, these assumptions may or may not be misplaced. New technology has been crucial in uncovering new planets and their secrets, and it will be crucial in finally beginning to uncover how peculiar, or not, our own planet actually is.
Yeah, I think in the study of other planets, we are just seeing the tip of the iceberg. So all of these questions are now to the stage that we actually have the technology in order to start to answer them. It's going to take still quite a while. It's probably still going to take a number of decades before we have some of the answers. But at least we are the first generation of scientists that have most of the technology now in-house to start answering some of these very fundamental questions.
And while we've come a long way in the past half-century to understand both exoplanets and our neighbours in our own solar system, those fundamental questions are very wide-ranging indeed.
We really don't know as much about exoplanets as individual objects as we did about the planets in our solar system 50 years ago.
Although there are many tasks on the planetary checklist, for Paul, the next goals in the search are glaringly obvious.
It's finding Earth 2. It's finding, Earth analogs. And then, of course, the $60 billion question: do any of these things have life? Is life common? Or is it rare?
So, what is our place in the universe? How special is Earth? Over the last half-century, we've landed probes on our neighbours and caught glimpses of thousands of planets around distant stars. These results show that planets are abundant and hint that there may be not just one, but countless Earth analogues out there in the universe. Or perhaps our planet got lucky in ways we don't yet understand and is more unusual than we can imagine. Regardless of how our future observations shape our answer, we will always have a unique relationship with the Earth beneath our feet.
Every time I now look at Earth, then I think, wow, we have a beautiful planet. We better also take well care of it. Is it unique? We still don't know. But it's certainly worth realizing we are on a very beautiful planet.
I can say from personal experience that good planets are hard to find. For human beings, there will never be a planet anywhere near as good as Earth. We have literally evolved in every possible way to this planet. I know a lot of people dream of going into space. I really have no interest in going into space. If I had 3 or 4 days and nothing better to do, I wouldn't mind going and laying on the beach.
If you enjoyed this episode, we'd love it if you could share it with your friends, family, and colleagues so that they can know about Knowable too. We'd also love to hear your feedback. Write a review wherever you listen to your podcasts, tweet us at KnowableMag, and email us on podcast@knowablemagazine.org. And don't forget to subscribe so you don't miss episodes covering everything from how life takes shape to lessons from our climate's prehistoric past. In this episode, you heard from Jack Lissauer, Evina van Dishoek, and Paul Butler. The episode featured quotes from 5 articles published by Annual Reviews. They are Ingersoll and Leovy, 1971, Lissauer, 1993, Marcy and Butler, 1998, Wolf and Angel, 1998, and Seeger and Deming, 2010. You can find links to those papers and more in the show notes on our website, knowablemagazine.org/podcast. This podcast was produced by Knowable Magazine, a non-profit publication that seeks to make scientific knowledge accessible to all. Knowable Magazine is an editorially independent initiative from Annual Reviews. Explore more sound science and smart stories at knowablemagazine.org. I'm Adam Levy, and this has been Knowable.